Hello everyone, so this is the second video of ethers from MSc Elementary, and we are discussing from question number 11 to question number 20 in today's video. Let's come to the question number 11. The equation has been given to us, ethoxyethane has been given to us, and the concentrated HI in excess is reacting with it. We have to find out the major products. This is our ethoxyethane and we have an HI over here which is going to generate H plus and I minus. H plus will go first protonate your oxygen, and after that there will be an SN2 attack on any of these carbons. Let's suppose here it is happened. This bond is going to cleave and it is going to convert into CH3 CH2OH and CH3 CH2I. Now because we know HI is in excess, there can be one more reaction happen. There can be one more reaction which can take place with alcohol, and alcohol using SN2 will go through this. So basically it will become CH3 CH2 OH2 plus, and then I minus will attack. This will go out and you will get the respective iodide. So both of the products will be CH3CH2I, that is iodoethane, and that will be your major product. Now here, this is the compound given where we have to react with the HI and heat and find out what are the major products. Various different options have been given. We have to find out which combination will be the right answer. Let's see the answer. So this is the compound given to us. H from here will be protonating the alcohol. H plus will be attacking and will form the protonated alcohol. After this, I minus is present. I minus will either go through SN2 or SN1. Both the reactions are possible here because this is a benzylic position. The attack cannot happen on benzene because on phenylic position, neither SN1 nor SN2 can happen. So attack will happen on this and oxygen will go out as a leaving group. So we will get phenol and benzylic iodide. So this is your option number B. Second. Come to the question number 13. Again, very similar question. In question number 13, you have been given an cyclic ethers and one more ether, and they are asking what will be the product if we do the hydrolysis of this compound. Let's see the solution of this question. So here we have H3O plus. Your H plus will be attacking one of the oxygens, or you may say both of the oxygens at the same time. Either way you can do the reaction. Now, when the H plus is going to attack, you are going to get the protonated alcohols on both the sides. So this is the protonated alcohol on both the sides, and this carbon has a strong delta positive. So H2O is going to attack over here as SN2, and this will be going out. So this will form the species like this. So you have OH here. On this particular carbon, there is going to be strong delta positive also, plus repulsion between these two OHs also. So my H2O can further attack on this and can cause this bond to cleave, and it will form a diol like this, right? And this is alcohol formed anyways. Now this geminal diol is anyways not stable, so it will release the water molecule, and this is how the compound will look like. So I'll just repeat the whole thing. What we have done over here is we have done the acidified attack first on both the oxygens. The excess of H plus is there, then this delta positive is present over there. You can do it one by one also, either way is fine. Then H2 will attack on the carbon where these O groups are present, and eventually SN2 attacks a one bond will cleave. Then once the bond is cleaved, after that again this carbon is carrying a delta positive charge, and this is again the ether linkage is still present there. Even if you do the acidic attack later on, it will form this kind of structure, this kind of structure again. Then you can have a delta plus. Delta plus is more stable here. Due to minus I, there is a stronger delta plus here. So H2O will again attack on this carbon using SN2. Once you'll use SN2 and do this attack, this reaction can happen through SN1 also, SN2 also, both. SN1 bhi ho sakta hai. Why? Because the plus charge will be stable due to the presence of OH. So this reaction can go through SN1, can go through SN2. It may form the compound like this. And then also this will result into the respective aldehyde. Okay. Or it may go through SN2 and OH may come over here and the loss of water molecule may take place. So either way you can do this reaction. The products will be option C. So basically both A and B. Now question number 14, in which they are asking the reagent which will be suitable to distinguish 1-methoxy-3-methyl-2-butene from isomeric 4-methyl-3-pentene-1-ol. So first of all, we have to understand what is 1-methoxy-3-methyl-2-butene. So this is your 1-methoxy. This is this compound. This compound is your 1-methoxy-3-methyl-2-butene. This is on first position, the methoxy is present. On second position, the double bond is present. On third position, the methyl is present. Another compound is 1, 2, 3, 4, and 5. So this is your on first position, OH is given. Third position, double bond is given. And on the fourth position, methyl is given. So 4 methyl, 3 pentan, 1 ol. They are asking us to identify or distinguish between these two compounds using the given tests. Bromine, if we'll use in CCl4, both bromine will attack in both the cases, case 1 and case 2, because it is an unsaturation test. Bromine CCl4 basically decolorizes when reacts with a double bond, so it will give the test for both. Alkaline KMnO4 also is a syn hydroxylation reaction where KMnO4 ka pink color will disappear when the reaction will take place, and again it will show in both the cases first and second. Ammonical silver nitrate will not react with both of these because ammonical silver nitrate reacts with carbonyl compounds, especially aldehyde, not carbonyl compounds, mainly aldehyde. It's a test called as Tollens test. Okay, so this cannot happen here because we do not have any of the compounds in the aldehyde form. There cannot be a tautomerism in second case so that it may convert into aldehyde. No, that is also not happening. Hence, ammonical silver nitrate test will not happen. Now, the last one is sodium metal. Sodium metal test. Sodium metal will react with the acidic hydrogen. So where is the acidic hydrogen we have? We have here in the alcohol, and hence this compound will give the test, but the first one will not. So fourth one will be the right answer. Question number 15, again very common question. You have been given an ether, you have to hydrolyze and find the products. Very simple question. Again, H plus will first of all protonate your oxygen, will form this. Then we'll find out whether SN2 is possible or not, SN1 is possible or not. Both the chains are benzene. Neither SN1 is possible nor SN2 is possible. Hence, no reaction. No reaction will take place because of the double bond character in both the cases. So no SN1, no SN2. No SN1, no SN2 can take place in these positions. Question number 16, we have to find out the reactivity of the ethers in the given pair towards the hydrolysis. So towards the hydrolysis means hydrolysis can take place either through SN1 or SN2 depending upon what kind of chains we have. So let's see the question number 1. So basically pair number 1. So in this pH and pH is given, basically both are benzenes. Neither SN1 can take place nor SN2, hence reaction will not happen in this case. Whereas in this case on pH the reaction will not happen, but SN2 is quite possible and very fast. Hence this reaction will be faster. In fact, this reaction will not even happen. Come to question number 2. In this case, the compound given 1 is benzene. So benzene pe to neither SN1 can happen nor SN2. On the other chain, there is a 3-degree structure which can go through SN1. And here is a bridge head which is not again capable of doing SN1, SN2 both effectively. Hence the second option would be more faster in the reactivity. So according to this, in first case out of A and B, B is faster. In second case out of C and D, D is faster. This is your option number C. Now again in question number 17, we have to just do the reaction with HI and see whether the reaction is SN1 or SN2. Now the condition for hydrolysis is if there is a 3-degree carbon present next to the oxygen and 1 degree, then the reaction preferably go through SN1 because it is capable of forming a better stable carbocation. So after this is achieved, the molecule will automatically cleave in such a way that electrons will be taken by oxygen. This CH3 supports SN2, this supports SN1, but even before any attack will happen, this will cleave into a carbocation and CH3OH will be formed. This happens mainly in case of 3-degree carbon chains. If they are present next to the oxygen, carbocation will be formed and then I- will do the attack on it. It will not be through SN2, it will be through SN1 because the carbocation has been already generated. So answer for 17 is A. Now come to question number 18. In question number 18, we have been given a cyclic ether with 3 oxygens and we have to do H3O plus hydrolysis and find out how the products would be. So let's understand, this is a little longer question to solve. I have done the hydrolysis one by one on each oxygen. So if I do OH plus over here, because the H plus will come and protonate this oxygen. After this H2O will attack and it will attack on any of the carbons over here. Okay? And this chain will open. Now when this chain will open, this will open like this. This will become OH and H2 is connected over here. H plus is out and we got OH here. So diol we got. Now repeated process will happen when the excess of H3O plus is there. So one more H plus is there. It will go to one of the oxygens, this oxygen, and it will attack on this oxygen, will form OH plus. Here there is a stronger delta positive because 2 electron withdrawing groups are present. H2O can attack over here and this will become something like this. OHCH2 OH2 plus. Okay, and then it will lose its H plus. This H plus will be gone. It will become CH2 OH, which will eventually lose water molecule because it is geminal diol, and it will become an aldehyde. Another molecule would be this part. So it is OH, CH2O, CH2OH. Now again, H plus attack will happen on this oxygen, and again the same process will take place. So your H2O after this will attack on this carbon, and the bond will cleave. Two oxygens are there, delta plus is very strong over here, H2O will attack, and this will cleave. When it will cleave, it will be CH2OH on this side, and it will be CH2OH on both sides. Both are geminal diols. In both cases, loss of water molecule will take place, and two formaldehydes will form again. So basically total number of 3 formaldehydes will be generated in this reaction. So you can do this reaction one by one, and you will understand that after doing all the 3 steps, or all 3 times the hydrolysis, you will get 3 formaldehydes in this reaction. Now come to question number 19. In question number 19, again we have to do the hydrolysis of this molecule, and again I'll try to do it one by one. So we have taken H3O plus over here. If I'm attacking with H plus, it will form OH plus like this. Then this carbon has a stronger delta positive, and this carbon has one oxygen. So there is a higher probability of forming cation also over here, because it can form a better stable cation due to the plus M. So in the previous case also, it was quite possible formation of a cation directly rather than SN2 being happening. So both are possible. SN1 is also possible, SN2 is also possible. Cation formation is also possible. So we cannot detect here whether SN1 or SN2 is happening, because carbocation formation is quite feasible here due to the presence of plus charge and plus M stability. Okay, so I have shown it through SN1 so that it becomes easier, because it's not going to bring any difference in the answer. So let's suppose this bond cleaves. Okay, you'll get a plus charge over here. Okay, and what will happen in that case, this chain will open. If you see here, this is first is formed. Okay, and then this bond is cleaved, and this it is forming this, and H2O is there. H2O is attacking over here. OH2 plus is formed on this position. It is losing its H plus. Okay, so I have open chain OH here, one OH here. H plus is out, and that H plus, the H plus which is out here, that can go and attack on the oxygen and forming OH plus. Either this H plus can be the one which water has lost. This H plus which is out can attack on this oxygen directly, or H plus from the solution, either way, and it will eventually form OH plus. Now once this OH plus is formed, it is similar situation as before. Okay, this oxygen will try to cleave the bond, and the carbocation formed will be very stable because it is getting plus M stability. So it will cleave. Now this oxygen may lose its hydrogen. H plus is out. It will form the respective aldehyde, and OH is there on both the positions. It is not very sure that it is reaction is going through SN1 or SN2, or maybe both can happen in this, because both possibilities are there. Delta plus is very strong. Even it may break as directly plus charge over here. I have written plus because I feel that it should form a carbocation here, because it is getting very good stability. It is getting very good stability, plus M stability. That is why I have gone through SN1 over here. Similar thing we could have done in the above case also. So we could have broken it one by one, but the only problem is, in case of SN2, it may face a slight repulsion due to the already present OH, but I don't think that can be a major factor. The reaction may happen through SN1 or SN2. One reaction I have shown you using SN2 type of mechanism. Another reaction I have shown you according to SN1 type of mechanism. I think both would be happening in parallel, but both will give you the same product, no difference in the product formation. Now come to question number 20. In question number 20, again we have to do hydrolysis. I think answer of this is given wrong in the book, and in this it is a very simple question. We have to do the hydrolysis by adding H plus again. So I will have a protonated alcohol over here. Then this, on this carbon there cannot be any attack because this is a vinylic position, so neither SN1 nor SN2 can happen. So through SN2 the attack will happen here, and it will simply form this and ETOH2 plus, which will ultimately, after losing H plus, will form ETOH, and this molecule will be formed, which is enol. Enol can tautomerize to form keto. So it will form cyclohexanone plus ETOH, which is option number B. So here we are done with our 10 questions from 11 to 20. In the next video, we'll be discussing from question number 21 to 28. Thank you.